All right, well, good morning, everyone. Welcome back to another exciting day of mathematics. Whoop, whoop. How's everybody doing? Good? Warm-up 106 is on the screen. By now, numbers 2, 3, 4, and 5 should be automatic. I'll go over number 1 just to refreshing your noodle. But other than that, yeah, let's do this. Warm-up 106. Give you some time for that. That's fine, that's fine. Yeah. All right, here we go. You all ready? Simplify. Number 1A. Look up to the screen. We're going to simplify that without writing it in decimal. So I'm going to look for two numbers that when you multiply them give us 90. What two numbers multiplied give me 90? Tell your neighbor, what two numbers multiplied give me 90? Martin, what two numbers? Yeah, 9 times 10. Woo! Martin in the house. Let's go. Therefore, square root of 9, square root of 10. What is square root of 9, everyone? 3. And we're left with square root of 10. This is how I want it written. By now, we already know how to do the approximate decimal form. Is that correct? So let's start practicing this form. Let's go to number 1B. Let's rewrite this. This becomes square root of 81 over square root of 7. So, what is square root of 81? Tell your neighbor, please. Square root of 81 is 9, and we're left with square root of 7. However, reminder, can we have a square root on the denominator? No. Remind your neighbor what to do with that, please. And then Jacob's square will get us started. What do we do to get rid of that square root on the denominator? Jacob squared, what do we do? Very good. He said multiply top and bottom by square root of 7. That is correct. Multiply top and bottom by square root of 7. So that leaves us with 9 square root of 7 over 7 times 7 is 49, so square root of 49. So 9 square root of 7 over, what is square root of 49? 7. And that's how you get rid of the radical on the denominator. Okay? You guys remember this, yeah? Yes, Mr. Q, we love these. All right, let's go to number 2. Number 2, give me a second. We need a sum, so that means adding these together. What'd you get for the sum? Rebecca, what'd you get? -2 plus 6i. Hands if you got that. That is correct. And remember, we need to write the I at the end. Okay? So far, so good. Let's go with the difference. Difference, which means subtraction. What'd you get for that? Let's go over to the front. How about Martin? What'd you get for the difference? That is correct, man. Martin from the front. Let's go. And product. Show your neighbor what you got for product when you multiply those. What'd you get? Product. What'd you get for the product for that one? How about Brandon? Darty. What'd you get? Hold on. You said -72i squared. What else? Minus what? 240i. Minus 468. what you said? 468. Okay, let's see. That and that. Negative 6 times 18. 48, got 4. 108. Aren't you missing something? Is this negative 108i? So this is a total of negative 348i. Is that correct? And then at the end it's negative, instead of 468, it should be 360. Yeah, right? All right. However, this is I squared. This is what? Negative 1. So that's 72. Answer for the product. It's negative 288 minus 348i. Hands if you got that. Let's go. All right, factor by grouping. By now you should know how to do that. So the factors for that are x minus 5 and x plus 3. Hands if you got that. Okay. Let's go to number 4. This is something that I want to see to make sure you're understanding this portion. Now to graph that, here goes. Let me recap because we're about to get into a lot of graphing starting today. Yay! Good thing you practice over the break, right? Good. Here we go. And I miss, before I came to the high school, I used to teach at the middle school. Do you guys know that? And you guys are lucky because at the middle school, I used to leave a packet of work for spring break. Only 150, I think it was 158 problems for the, that was good, like to distribute over the days. Right? Extra practice. All right, so this is squared. That means our parabola is right here. So far, so good, yes? Remind your neighbor what's going to happen to the parabola, where we're going to move it to. Remind your neighbor. We're going to move that to. Danny, go. To the right. 4 to the right. And 5 down. So my new vertex is at 4 to the right, 5 down, so it's 4, negative 5. So 4, 1, 2, 3, 4, and 1, 2, 3, 4, 5. So this is my new vertex. However, before I move it, what does this do? The 1/2 right there in the front. Tell your neighbor, what does that do to the parabola, the original? Looks like Rebecca's got it. Very good, Rebecca. Claire's got it. Very good, Claire. David, he's all like, oh, I got this, cute. Well, let's go with Jacob. Jacob, what does this 1/2 do to the entire original function? Did everybody hear that? He said it doesn't stretch, it what? It shrinks it. Makes it smaller, something like that. So now that we have it shrunk, we bring it down here, and there it is. So question, look up. They're asking here, state the domain and range of this one now that we have it there. So this is what you do. Look up. You look at the function. What x value should I use to see the actual parabola being formed? Well, I need to go maybe from here to about right there. So what values? 1, 2, 3, 4, 5. 1 all the way to what? 5. So my domain is from 1 to 5. How about the range? We got -3, -4, -5. I'm going to go one more, -6. So my range is from -3 to -6. So like that, I can see that. Now, why didn't I use from -2 to 2? Talk to the neighbor. Why didn't I use from -2 to 2 as my domain? Why do you think I didn't use that? All right, good conversations. Jay, why didn't I use from -2 to 2 for my x value so I can see this? Did everybody hear that? He said because if you would have used from -2 to 2, Mr. Q, which is from here to here, you wouldn't be able to see this. Everybody see that? If I'm using these values for x, will I be able to see this parabola? No, the parabola is way over here. That's why I'm using the domain from 2 to 5, from 1 to 5. My bad, 1 to 5. I could go from 2 to 5, but I did 1 to 5. There it is. If I use anything before that, I won't be able to see the parabola. Anyways, last but not least, find the slope between the points. Remind your neighbor how to find the slope for those, please. Very good. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You guys remember that? Yes? This is my x sub 1, y sub 1, x sub 2, y sub 2. So, I'm going to start with y sub 2, x sub 2. Y sub 2, x sub 2, y sub 1, x sub 1, y sub 1, x sub 1. So, this is -7, negative times the negative is a +5, -4, negative times the negative is a +1. So this is -2 over -3. So my slope is 2/3. Now for right now, I'm going to stop right there. I know they're asking us to write an equation, but just for the sake of time, because I want to move on, send me your warm-up, please, and copy the agenda. Code for the home plate, QJUTW. 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 All right. So, with that said, get a Cornell note going, please. Tonight's home play, you're going to have a play sheet. I think there's only like, I want to say 4, let's see, 1, 2, 3. I think it's 8 problems only. So, make sure you get those done. Our objective for today, I can graph polynomial functions. You don't need coordinate planes set up. We're going to be building them as we go. But just get a Cornell note set up, please. And you do need a Freire model. You do need a Freire model. Give you some time to set that up. All right, here we go. Once again, I can graph polynomial functions. It's going to go pretty fast, so everybody go like this really quick. Like this. Bear with me. Y'all ready? All right, so quick recap. Look up to the screen. By now, you should know what polynomials are, yes? All right, remind your neighbor what polynomials are. Don't copy that. Remind your neighbor what polynomials are. What are polynomials? Once again, you're not writing that. This is just a recap. Polynomials are what? Monomials or sum or difference of monomials. and they look like this, and so on and so forth. You already have those notes, yes? All right. Next, I gave you guys the names of the polynomials according to degree and according to term. You guys remember those? Yes? Yes, Mr. Q. All right. Next, what is a function? Remind your neighbor the definition for a function. What is a function? Now, you better know this one because I'm going to send Kimberly to slap people around. My goodness. Again, function. What is a function? Jay, pass someone. Brandon. Felix. A function. All right, close. We said it was a relation that there's exactly one output for each input. All right, and we know what they look like and so on and so forth. So, taking those two ideas, polynomial function, what are they? Write that in your fair model. What are polynomial functions? Let's see, think about those two previous ones that we talked about. And in your own words, share with your neighbor what you think the definition would be for a polynomial function. What would be a definition for polynomial function? Pass someone, Brandon, Felix. Jacob squared. Polynomial function is? Again with the 2 points. All right, here goes the definition. Write this down. A standard form polynomial that is a function. That's as simple as it can get. A standard form polynomial, that means from highest degree to lowest degree, written in function notation that look like this. F of x equals 2, f of x equals x squared, f of x equals negative 3x to the fourth plus 2, and f of x equals x squared minus 3x plus 2. Write those down, please. As you're writing those down, and if you notice this one, this one, I forgot to put the equal sign right there. There it is. Equals to negative 3x to the fourth. All right. So those are polynomial functions, and they continue building, right? So, then why are these not? Tell your neighbor, why are these not polynomial functions? Why are those not polynomial functions? All right, why are those not? Riley! They don't have the equal sign, that is correct. And what else don't they have? F of x, that is correct. So, hashtag, what would be our first hashtag, everyone? Hashtag equation, yeah, equation. Hashtag f of x. And maybe one more, hashtag polynomial. Polynomial. All right. So, quick recap. Look up to the screen. You already have these notes. I left you guys a video lesson for these notes, but I'm going to recap one more time. Look up to the screen. If I give you the function, look up please, f of x equals x. The graph looks like this. For a positive, or like this, for a negative. But right now we're going to stick with the positive one. There it is. Now, if I was to graph this in the coordinate plane, here's my coordinate plane. We have quadrant 1, 2, 3, 4. So, where does it start? If we're reading it from left to right, it starts at quadrant 3, and it ends at what? Quadrant 1. Is that correct? From there, if we go to f of x equals x to the second. Here's my coordinate plane. Here's my parabola. What quadrant does it start? At quadrant 2, and it ends at quadrant 1. F of x equals x cubed. Here's my coordinate plane. It starts down here, and it does the wiggle, and it ends up here. So it starts at quadrant 3, and then ends at quadrant 1. And I'll do one more. Here goes. F of x equals x to the fourth. That one looks like this. Look up, please. What am I talking about? You probably took copious notes. That's fine. It goes like this. It kind of looks like a parabola, but it extends a little bit more. It starts at quadrant 2, and it ends at quadrant 1. So, according to what I left you guys to look up, please. Notice that this first one starts at what? 3, and it ends at 1. Do you see any other one that ends at 1 and it starts at 3? Yes, this one and this one. What do you guys see that they have in common? Well, what is the exponent, invisible exponent there, and what is the exponent here? Tell your neighbor. Exponent on the first one. What would be the invisible exponents? A 1. What kind of numbers is 1 and 3? Tell your neighbor. Yes, these are odd. Therefore, do we see anything else with the other ones? Well, the other one starts at 2. It ends at 1, 2, 1. What is the exponent here? 2. What is the exponent here? 4. What kind of exponents are those? Those are even. So what can we conclude? That odd exponents start at quadrant 3 and end at 1. Even exponents start at quadrant 2 and end at 1. So all of them end at 1, but odds start at 3, evens start at 2. Okay. Let's try this. Here it goes. Y'all ready? All right. So, don't write this down. Let's say I gave you f of x equals x to the 23 power. We don't know what that graph is going to look like, but we know where it starts and where it ends. Tell your neighbor where it starts and where does it end. Where does it start and where does it end? All right? Mitos, where does it start and where does it end? Starts at what? 3. And it ends at 1. That is correct. Starts over here and it ends over here. There's going to be a bunch of stuff in between, but that's where it goes. Why? Why is that correct? Jacob. Yes, because this is an odd exponent. Starts at 3 and then ends at 1. Let me show you another one. F of x equals to x to the 100. Tell your neighbor where that one starts and where does it end. Trinity, go. I couldn't hear you with the AC. 2 and 1, yeah, starts over here, and it ends over here. Why? Because it's an even polynomial. All right? So with that said, copy this one on your paper, please. Example 1. Sketch the graph of the polynomial function. F of x equals x times x plus 2 times x plus 5. Once again, this is going to go pretty fast, so stay focused, please. You all right over there, Danny? Okay. Step 1, set it equal to 0. So set that equal to 0, x plus 2, x plus 5. Tell your neighbor the next step from there. What do we do next? Your brain should be able to pick up that next step. What do we do next, Bree? Close, because we're solving from this point. Help her out, Anthony E. Yeah, set them equal to 0. So x equal to 0, x plus 2 equal to 0, and x plus 5 equal to 0. And now all we do is solve. Here we go. Is this one already solved? Yes. How about this one? Minus 2 minus 2, x equals negative 2, minus 5 minus 5, x equals negative 5. All right. And once again, in case you forgot, these are called what? My solutions. X-intercepts, zeros, or roots. So, look up really quick. We're going to graph this. So, follow along. Sketch your coordinate plane on the side. It doesn't have to be perfect like mine, I know. Just like that. And if these are called x-intercepts, what's my first x-intercept? It's at what? 0. So let's plot that. The next one is at negative 2. 1, 2, right there. And the next one is at negative 5. 3, 4, 5. Okay. So now that we have our zeros down, focus please. Writing utensils down, look up to the screen. Look up to the screen. Look up to the screen. How many zeros do we have? 3 of them, right? That means that the parent function, pay attention to this, was like this. Because of how many zeros? There's 3 of them, right? So what kind of polynomial function is this? It's an odd. Tell your neighbor where that graph starts and where does it end. Where does it start and where does it end? All right, enlighten us. J, where does it start and where does it end if it's an odd number polynomial? 3 to 1, so it starts down here. So check this out, look up. My last point here on the third quadrant is here. So I'm going to make my arrow a little bit to the left right here. And it's going to end over here at 1. All right, so I'm going to start at the arrow, look up. I go through the first point, bring it down to the second point, to the third point, look, and we're done. And that's how you graph your polynomial functions. Ooh-wee. All right. All right, up to right there. Here goes the process one more time. What is the first thing we did? We set it equal to 0. From there, each factor equal to 0, and then we solve. And that gave us our x-intercepts, or our zeros. We plotted those. But then we needed to know what kind of function this was, and we said since there's 3 zeros, that means the parent function should be x cubed. That means it's an odd. That means we start at quadrant 3. Once again, those of you that are a little bit lost, this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. We start at quadrant 3 and at quadrant 1, and then we just go from left to right, connecting the points all the way to connecting the arrows. From 1 to 5, how comfortable are you with that so far? All right, you do one by yourself. Here's the next one. Copy this. Example 1Q. F of x equals x times x minus 3 times x minus 7. You should be able to solve and graph, and I'm going to send you the screen so you can send me your work. Go. All right. Here's one from one of your colleagues. Double check your work. Look up to the screen. Hands if you got something like that. That is correct. All right, send in what you got so I can see your work. All right, copy this next one. Example 1, super cube. F of x equals x times x plus 4 times x minus 4. See if we can go a little bit faster on this one. All right. Help me out on this one, please. Did I call Anthony E already? Anthony E, pass someone. Anthony D, go. What do I do? Set it to 0, and then set them all to 0, all the factors, and solve. So, what is this one? X. Continue. Okay, so we graph that. All right. So, we got 0. We got 4. We got -4. And where does it start? Where does it end, Anthony D? Yeah, I'm saying what quadrant? 3. And it ends at 1. Always ends at 1. And once again, there's 3 of them, so that means the parent function should be f of x equals x cubed. So we go through the first one, second one, third one, and we're done. Hands if you got that by yourself. From 1 to 5, how comfortable are you with this so far? Yeah, 5, 5, 4, okay. Send me your notes. Let me send you the screen. Give me a second. All right. Look up. Don't copy this one. Look up. Look up, look up, look up. Without copying it and without doing all the work on paper, tell your neighbor what the x-intercepts are. What are the x-intercepts? X-intercepts, Rylan. -2, +2, and +4. And we start at what quadrant for the graph? Third quadrant, and we end at 1. Hands if you got that? Yes? We got this, yes? All right, copy this next one. Example 1, super duper cube. F of x equals x squared times x minus 5. We're going to do this one together just because it's a little bit different, just a little bit. Process is the same. Step 1, set it equal to 0. Are we there? Look up, please. Next, set each one equal to 0. However, can I write this one in factored form? Yeah, x times x, right? X times x. Now we set it equal to 0. X equal to 0, x equal to 0, x minus 5 equal to 0, and we solve. This one solve, that one solve, and this one plus 5, x equals 5. All right? Writing utensils down, look up to the screen. Writing utensils down. Look up. My first is 0. My second one is also 0. Look up, please, or you're going to miss it. And the last one is 5. What do you guys notice from this one to that one? It's bigger, right? Why? Because there's how many of them stacked on one on top of the other? 2 of them. Is that correct? All right. Now, question, how many total zeros do we have where x intercepts? 3 of them. Is that correct? So my parent function is f of x equals x cubed. That means it starts over here, and it ends up here. Are we there so far? Okay, here goes the graph. Ready? Pay attention or you're going to miss it. Whenever we have a double root, you don't go through it, you bounce off of it. Copy that. Label this and make a little note for yourself. Bounce off of it. With your code, you're going to have access to the play sheet, guys. Enjoy your home play. See you guys tomorrow. Bye.